Good day everyone and welcome to our channel. For today's video, we are going to discuss about factoring polynomials with common monomial factor. By the way, I am Ma'am Coren, your teacher for today. Before we have the common monomial factor, let us review factoring. So factoring, it is finding two or more factors of a number or a polynomial. And then factoring a polynomial, it is rewriting a polynomial as a product of polynomials of smaller degree. Factoring is the reverse of multiplication, wherein we get factors instead of products, out of the products. So the greatest common factor of two or more monomial is a common factor having the greatest numerical factor and with the variables having the least degree. Thus, the term ax raised to n is the GCF of a polynomial if a is the greatest integer that divides each of the coefficient of the polynomials and n is the smallest exponent of x in all of the terms of the polynomial. So, to understand this further, let us have the following examples. 6a and 18a. So, according to our discussion a while ago, the numerical coefficient must be the greatest number wherein it is the factor of the terms. So, what is the common factor between 6 and 18? So, to do that, we must factor out 6a. So, 6a, to get 6a, we have the factors 2, correct, times 3 times a. How about 18ab? So if we have 18ab, this can be 9 times 2. So we have 2. And then we can further subdivide 9 into 3 times 3, correct? So we have 2 times 3 times 3 times a times b. So these are the factors of 6a and 18ab. To get our GCF or the greatest common factor, we simply have or multiply which factors are common to the two terms. We have here 2. So we copy 2. We also have a common factor of 3 and also a. So we have 2, 3, and a. They are both present in the two terms. Can you see other factors that are also common to 6a and 18a? B? None. So that is only 2 times 3, which will give us 6a. So therefore, the greatest common factor of 6a and 18ab is 6a. So let us have another one. So in this example, we have 10a and 12a squared b. So again, let us find or get the factors of 10a. Correct. So 10a can be subdivided into 2 times 5 times a. How about 12a squared b? Correct. For 12a squared b, 12 can be written as 4 times 3. And 4 is actually equivalent to 2 times 2. So 2 times 2 is 4 times 3 will give us 12. So these are the factors of 12, prime factors of 12. And then for a squared, we have a, and then a, and we also have b. Again, to get the greatest common factor, we find the factors that is both common to 10a and 12a squared. So what are those? So we have 2 here. How about 5? 5 is not present in the factors of 12a squared and b, so that it would not be considered. How about a? Yes, we also have a in 12a squared b. So the greatest common factor of this two terms is 2 times a, or simply 2a. For a third example, let us have negative 8x squared and 16xy. So we can have the factors of negative 8x squared y be written as 8 is actually equivalent to 2 times 2 times 2, correct? Let us remove the negative sign for a while, or we place it outside the parentheses. So that is 2 times 2 times 2. How about x squared? Yes, that is x times x. And then for y, we have times y. How about 16xy? We know that 8 times 2 is equal to 16. So we add another 2 to 2 times 2 times 2 for us to have 16x times y. Again, to get the GCF, you find the numbers that are both common in negative 8x squared y and 16xy. Only one of them has a negative sign, so it is not counted. We have three twos here, so we can get the 3 twos as their common factor. For x, we also have 1x for 16xy. That's why we cannot have it as x squared. Then we also have y. So let us multiply the terms to get our GCF. So this is 8xy. So the greatest common factor of negative 8x squared y and 16xy is actually 8xy. So in this example, we are going to factor completely by applying the greatest common factor. So we have 3x plus 6. By merely looking at the two terms or the binomial term, what is the common factor between 3 and 6? Yes, both terms are divisible by 3. So their GCF is actually 3. And then we get the other factor since we are told to factor it. Since we have here 3, we divide 3x by 3. So 3 divided by 3, that is 1. And then since 3 do not have a variable with her or with it, so we have here as x. And then we have 6. 6 divided by 3, so that is 2. So the factored form of 3x plus 6 is actually 3 times the quantity x plus 2. If you are not sure with your answer, you may double check it. So let us multiply, since I told you a while ago that the reverse of multiplication is factoring. So to get the product, we multiply. So we have 3, distribute it to the terms inside the parentheses. So 3 times x, that is equal to 3x. And then 3 times 2 will give us positive 6. So since we have the correct answer, or we have the same answers, therefore our answer or our factors are correct. Let's try another one. Let's have 15x squared y cubed minus 33x y cubed. So what is the common factor between 15 and 33? If you are not sure with the factors, again, you may list down their factors to get the greatest common factor. 15 can be written as 5 times 3, while 33 is actually, yes, it's 11 times 3. Notice that they both have 3. So therefore, one of the greatest common factor is 3. And they also have the same variable, which is x and y. So we write here x and we also write y. Now, according to our definition a while ago, the exponent of the variable must be the smallest one in the given terms. So as you would notice, this is only x raised to 1 while the other one is x raised to 2. So we are going to apply x raised to the first power since the most common is x. While for y, they are both raised to the third power. So we write here cube. If one of the other is just y raised to the second power, we only write y squared since that is the lesser or the least number of exponent of y. So going back to the other factor, we divide this GCF, or we divide the given by our GCF. So we have 15x squared y cubed. So we divide 15 by 3, which will give us 5. And then we are also dividing the variables. But when we are dividing variables, according to the law of exponent with the same base, we simply subtract the exponent. So if this is 2, 2 minus 1 will give us 1. So may natira pa tayong isang x. How about y cubed? So since they are both y cubed, so y cubed divided by y cubed, so that is 3 minus 3 when it comes to exponent. And y raised to 0 is actually equal to 1, which we do not write since 5x times 1 is simply 5x. And then we have 33 divided by 3, which is actually equivalent to 11. And then again, we have x divided by x. We have the same exponent. So this is actually equivalent to 1. We also have y cubed divided by y cubed. So that is also equivalent to 1. So our factored form of the given is actually 3x y cubed times the quantity 5x minus 11. Once again, you may recheck your work by multiplying the factors. So we can have this as 3x y cubed times 5x, which will give us 15. We add exponent 1 and 1, so that will give us x squared, and then we have y cubed. We are correct with the first term. How about the second term? So positive 3x y cubed times negative 11. So 3 times negative 11 will give us negative 33. And then we have x y cubed. So we have a correct answer since the product is similar with the given. And then for our last example, we have 6a and 20a squared b. So let us list down the factors or the prime factors of 6. Yes, it is 3 times 2 or 2 times 3. How about 20? Yes, we can have 4 times 5. But we can subdivide 4 to 2 times 2 times 5. So what is a common factor? So that is 2. So we can write this one as 2. How about the variable? Is there a common variable between them? Yes, that is a. Can we write b as another common factor? Correct. B is not present in the first term, so therefore b is not a common factor between the binomial terms. So we only have 2a. For the rest or the other factor, again, we divide it. So 6a divided by 2a is equal to, correct, that is 3. Do we need to write a here? Yes, there is no a since 6a only have the first degree variable. Next one, I think this is plus. So we have 20. 20 divided by 2 will give us 10. So we have 10. Common factor is a. So a squared minus a will give us a. and then we have remaining b. So our answer is 2a times the quantity 3a plus 10ab. So again, let us check our work by multiplying our answer. So 2a times 3a times 3 will give us 6a, while 2 times 10 is actually 20, and then a times a, that is a squared, then we have b. So once again, we have a correct answer. So let us have a real-life application of this factoring. We know that the formula for perimeter is always given by perimeter is equal to twice the length plus twice the width, where L is the length and W is the width. So let us use factoring to rewrite the formula. We are always use 2 with this formula. But what if we rewrite this formula perimeter by applying our factoring we just have learned? So perimeter is actually equal to 2 length plus 2 width. Is there a common factor between 2 length and 2 width? Yes. 2 is actually present in this case. So we can have 2 as the common factor. So we place it outside the parenthesis, and then 2L divided by 2, that will give us length, and then 2V divided by 2 will give us the width. So therefore, our new formula for perimeter is actually 2 times the quantity length plus width. So therefore, we can add first the length and the width, then multiply it by 2 before having the perimeter. Unlike the usual formula wherein we multiply the length by 2, also the width, and then that's the time for us to add. We minimize the steps in solving for perimeter. So that is one function of greatest common factor in real life situations. So I guess this ends our visual about common monomial factor, and I hope you learned a lot from this video. If you have questions, feel free to comment in the section box. Thank you so much and God bless.